Hello. So in this tutorial I will use ImageJ to try to quantify and measure those muscle fibers here that you can see here. If I just draw them so you can see what we are talking about, something like this here. The problem is that doing this manually is really tedious, and there is no real simple automated way to do this. If you try to convert this image into grayscale and do a kind of thresholding, it will just not work. It's quite difficult to do this properly. So let me just go back to the original image here. So, by the way, this image is a sample, a small sample from a slide scanner image that I have loaded up into ImageJ here and cropped. So I saved this small sample just for the sake of the demonstration. Let me just show you how to load the original image if you want to, but I will not go through this completely since it takes quite a long time. We go to here, open, let me select the CZI file here, and you will get this import dialog here first. Press OK. And then you will get this option, and make sure you select the first of all the sample that comes from the right scene. Since it comes from a slide scan, you have several scenes here, and also the highest resolution here. So once you click OK, you will have a multi-channel image that you will need to convert to RGB. And again, it takes several minutes here since ImageJ has to load up everything into memory, so it takes quite a long time. So, but let's focus on this image right now, which is a sample, and how can we tackle this issue of detecting those muscle fibers here. So, in this sample here, what we first need to do is try to separate those fibers from the rest. In order to do that, we will use what is called a color deconvolution. So make sure your image is RGB first, and go to Image, Color, and Color Deconvolution here. And with this nice tool, you can see that you have several vectors to choose from. So those are the stains, and the one that works well in this sample is H&E2. So let's do this. Press OK. And what you will see is that you get this legend here with the three different stains. So the residues, the eosin, and the hematoxylin. So let's get rid of the channels we don't need for the moment, and you can also save this legend for further use if you want to. And we will work on this image, which is a bit easier to analyze. So, by the way, we will use two plugins for Fiji. The first one is Stardist to do the detection, and we will use also MorphoLibJ for refinements. So you can install those plugins by using the help menu, update, and you will get this small menu here, this normal dialog box, and here you can go to manage update sites and choose Stardist. So it's listed here as Stardist, and the other one is MorphoLibJ, but this one is listed as IJPB plugins. So make sure you check those tick marks here, press apply change, and restart Fiji. Once it's done, you should have in your plugin lists MorphoLibJ and Stardist. So just for the sake of this demonstration, here I will just convert this image back into grayscale. So actually it's already grayscale, since you can see it's type 8-bit, but the problem is that the lookup table is pink to reflect everything. So let's put this back to grays. And now if we do edit and invert, this image looks like a fluorescence image, which is nice because now we can use it for Stardist. So let's launch Stardist. In Stardist 2D, which is normally a plugin meant to detect cells and objects like cells, here we will use it to detect muscle fibers. And for this we choose the versatile model here. You can leave the parameters by default. If you have changed those thresholds here, you can set optimized post-processing thresholds here for selected model to make sure this is done, and just press OK. So it takes a few seconds to process. It will obviously be much longer for larger images. And then you end up with a label image here with all your individual regions and regions that are stored in the ROI manager. So you can display them. Oops, sorry. Put this back here. So I don't know if they show up really easily here in this. Yeah. You can see the region here. Anyway, we don't need the ROI manager here for the moment. What we need is really those regions here. The problem is that you can see we have also very small fibers or objects, round objects that were detected, and we want to filter them out. So in order to do that, we will use the other plugin, which is MorphoLibJ. So we go to MorphoLibJ here. And since this is a label image, we can go to the label image menu, and here we will filter by using label size filtering. So here we want to keep all the regions that are greater than, let's say, it's in pixels, so 500 pixels, for instance. And now we get a much nicer region, set of regions, so we can close this one. But there are still some few issues, like for instance those very bright regions here are actually, I don't know if they are muscle fibers or maybe blood vessels or something like this. So what we want to do is also get rid of those bizarre regions, those outliers, for instance here. So this spot, for instance, here is detected as a fiber. I want to remove this one also. So in order to do that, we will use a small trick by using the plugin MorphoLibJ Analyze. We can grab the intensity measurements from those regions. So make sure you select the label image here before choosing MorphoLibJ, Analyze, and Intensity Measurement 2D. And so in this one, it's okay to make sure, we want to make sure that sample RGB TIFF color 2 is the input, and for label we use label size fit here. Press OK, and we should get a table of measurements here. So now we can create a new map of labels based on those measurements. So let's select this one, and we will create now a new map. The color code will be based on the measurements. So MorphoLibJ, label image, assign measure to label. And here from this results table we'll choose the column mean, so to get the mean gray value. Press OK, and now we get a new map, but this time we have in bright the regions with the highest gray values. And with this there are several ways, but one way would be to filter it by using just a threshold, for instance. So we can choose image, adjust threshold, and let me keep everything, and we want to get rid of the highest intensities, like this. So I think this covers all the odd regions. Press apply, convert to mask, and then we can close this window, this table also. So now we are back to a black and white image, and but if you look here, those regions look fused together. So what we can do again is make a second round of Stardist. So let's close this image, go to plugin Stardist 2D. We can keep the same values here. So here it looks inverted, but it says specifically it's in inverting the LUT. So it's okay if it looks different from this image. We should get the same results. So again, it takes a few seconds, and here we go. So now finally we have our regions without those outliers here. There are still maybe regions that are a bit too small to be considered as fibers, so you can remove them further. Again, let's do just to repeat a bit the step. You can go here to label image, label size filtering. Let's go a bit higher than before. Let's say, I don't know, 1000. Okay, something like this. So now we are left with only the large regions which are not very intense. So now we can get the measurement about the area. The only thing that I will do just before that is that you can see here we have lost the scale. Here we are still looking at micron scales. So with this one selected, what you can do is go to Analyze, where is it? Set Scale here, and we will just check here Global. By doing this, we will apply the scale of this image to all the open images. Press OK, and now you can see that we are back to the scale in microns. It's quite easy to do. And then we can use our MorphoLabJ plugin to compute all the parameters and in the right unit. So analyze regions. You can also have the pixel count if you want, but what is interesting here is the area. That's okay. And we should end up, yep, with a nice result table. And now with this column here, you have all the sizes of the fibers coming from this image. So that's it. Thank you for watching. Bye bye.